Prussian. And for example, if we can observe, or if the RTE cells have absorbed hemosiderin, and that will stain with Prussian. One of the significant types or morphologies of the RTE cells are the oval fat bodies. So these are RTE cells that have absorbed lipid in the filtrate. Okay? And it can exhibit multi-cross formation using polarized microscopy or with the utilization of polarized light. So if negative, you have to check it with Sudan-3 and oil red stain. So there are other important facts associated with RTEs. The cholesterol polarizes and triglycerides and neutral fat stain, and the lipiduria, or in the case of the presence of lipids in urine, it is common in nephrotic syndrome. Okay, if you're asked to, if, for example, in a case study in the ASCP examination, or for example, it is presented as a case study. If you were asked between, if you are asked to choose between protein, or the presence of protein, the presence of blood, the presence of oval fat bodies, or the presence of cholesterol in urinary sediment, remember that the hallmark feature of nephrotic syndrome is always oval fat bodies. So oval fat bodies always points out to nephrotic syndrome. So you have to take note of those facts. This question must be given as a case study. So it cannot be given as a case study in your examination or in any examination. So nephrotic syndrome, oval fat bodies. Can you remember that? So also it is associated with acute tubular necrosis, diabetes, and also crush syndromes. Now, aside from epithelial cells, we can also see microorganisms in urine. For example, bacteria. Okay. So remember, accompany bacteria in urinary tract infection. Okay, and bacteria can be reported quantitatively. Like for example, it can be reported as few, moderate, or many per high power field. Okay. So you can also observe rods and cocci, but however, in urinary tract infection, because we know that the most common cause of urinary tract are bacilli or rods, like for example E. coli. Okay, so that's why you can observe rods more. Okay, but you have to take note that there are other organisms that can cause E. coli. It does not mean that if in some laboratories they only consider bacilli, they only consider bacilli, or they only observe for bacilli in urine sediment. They don't observe for cocci. But you have to take note that there are cocci that can cause urinary tract infection. Like for example, the saprophyticus or the Staphylococcus saprophyticus. This is a cocci. So therefore, it can cocci found in urine sediment can be clinically significant, depending upon the history and also the clinical manifestation. If that individual manifests symptoms of UTI and you can only see cocci in the urine sediment, then you don't have to conclude that it's not clinically significant because that patient manifests symptoms of UTI. And at the same time, if the physician has requested for a urine culture, so you have to depend also on the result of the urine culture if it is requested together with the urinalysis result. However, in some cases, in most cases, the urinalysis is usually released ahead of the urine culture. But you have to take note that a cocci that is seen in urine may be clinically significant because there are cocci that can cause, or cocci that can cause urinary tract infection. So remember, nitrite, since rods or bacilli are the ones converting nitrate to nitrite, it helps convert rods, not cocci. Okay, so we have to correlate this one. If we can see rods, we have to see the chemical evaluation if it is positive for nitrite. Next is a Trichomonas vaginalis. This is a pear-shaped flagellate. This is usually associated with an STI or a sexually transmitted infection, or contamination, or not contamination, but you can get it from using unsanitary or unhygienic toilets, like for example, pero in lesser frequency. Okay, but this is a common sexually transmitted infection. So it swims across the field very rapidly. Ibig sabihin, this means it is motile. And please take note that Trichomonas vaginalis is the common agent for the agent of ping pong disease. Okay? And of course, you will see WBCs in the urine sediment or in the urine itself, but you are nitrite or the urine is nitrite negative. Because what is causing the increase in WBC is not bacteria, but it is the Trichomonas vaginalis infection. And sometimes, okay, according to the literature, according to Strassinger, this Trichomonas vaginalis can be confused with RBCs. Okay, but however, since it is motile, it is impossible for trained medical technologists to confuse Trichomonas vaginalis with RBCs. Okay? So if not moving, they may resemble WBC, transitional epithelial cells, or RTE cells. Okay? And also, we can also observe Schistosoma hematobium and Enterobius vermicularis. Now, if we can observe Enterobius vermicularis in urine, then that is an indication that the urine that you are looking at is contaminated with feces. Okay? Your urine, or the urine that you're looking at is contaminated with, contaminated with feces. Okay? And this is Schistosoma hematobium. I think we discussed one in micropara. This is a fluke with a terminal spine that causes hematuria and infects the bladder. Okay? It infects the bladder and can cause certain types of bladder disorders. Sediment that you can observe in the urine is the spermatozoa. The spermatozoa is rarely significant because it talks about recent ejaculation, either through collection or sexual intercourse. So they are rarely significant. Okay. In some cases, if there is a mechanical problem with the bladder, wherein the sperm is expelled into the bladder instead of the urethra, if there is a mechanical problem in the anatomy of the patient, and that is why you can see sperm in urine. Now, it is associated with a lack of clinical significance. However, it can be implicated in legal consequences. Okay, you can see an oval tapered head with a long tail, and remember that in most cases, this spermatozoa is already immobile because the urine here is toxic to the sperm. Now, the reporting for the spermatozoa may vary depending upon the level of the protocol, and this spermatozoa may cause the positive protein reaction. Other casts, these are the elements that are unique to the kidneys. Okay, and they are formed in the distal convoluted tubule and also the collecting duct. Okay, and its morphology, you can observe a parallel side, rounded ends, and also sometimes it contains cells as inclusions. Like for example, we can observe RBC cast, WBC cast, and other types of cast. And once these RBCs or cells have been disintegrated, we can observe the fine granular cast and coarse granular cast. Now, this cast can be detected under low power, okay? And we ID them using the high power field, okay? And in the detection, remember that in the detection and the identification of cast, you have to use low light, okay? You have to use low light. So, these casts can be pathologic or non-pathologic. And the condition that is associated with the presence of cast in urine is called cylindruria. So you can see here the different types of cast. We have the hyaline cast, cellular cast, cellular to coarse granular cast, fine granular, and granular to waxy, and sometimes in certain severe renal disorders, you can see both casts.
Sa
So you can see here
ako na si
the
Tia dali
process
matudluan
of
na
cast
niya,
formation.
tudluan niya
So,
si
the tom morpho
Banana.
protein aggregates
Mas
into
mo
individual
Ako,
proteins and
na.
attach to the RT.
ito na na niya
Okay.
gihit
There
ang
are
dinding.
weaving fibrils to form a loose fibular network,
Kay maduha
and
dito
further
dito
protein
sa
fibrils interweaving to
nakit sa
form
mimin
solid
kay mo
structure.
na
And all of this happens within the tubular epithelium. Okay? possible attachment of urinary constituents to the solid matrix, which is why RBC cast, WBC cast, and if it is connected to pyelonephritis bacterial casts.
Pakikipa.
And also the detachment of protein fibrils to the epithelial cells. And what happens is that the cast matrix or the cast itself is released into the urine. Okay, so we have different types of cast: hyaline, cellular, first granular, finely granular, and waxy cast. And usually it follows the same arrangement in terms of formation. Hyaline casts have a low refractive index. They are colorless when unstained. And in the evaluation of hyaline casts, remember to use low light or phase contrast microscopy. Okay? And the normal morphology is a normal parallelized or convoluted. They can be wrinkled, cylindroid, and occasional adhering to cell or granule, as we can see here in our illustration. Now, there are different causes of hyaline cast or the presence of hyaline cast in urine. It can be either non-pathologic or pathologic. If non-pathologic, it can be seen in stress, exercise, fever, heat exposure, and dehydration. Pathologic, glomerulonephritis, pyelonephritis, renal disease, congestive heart failure. Now, we have to take note that in pathologic cases, we can see many, or we can see a number of hyaline casts in the urine. Okay, so we have to see also how many casts can you see in the urine. It should be correlated, okay, with the amount of hyaline casts in the urine for us to know that this is associated with pathologic cause or not. And if there is blood in urine, so blood and other sediments are associated with nephritis, then that can be
Ipang hipos na inyong mga
the presence of hyaline
sapatos dili ni balandra dira
cast.
kay.
The next is the RBC cast.
Nangipon ba na siya?
So if we hear RBC
Laro kayo
cast
ng
or if we
pagkikita
can
na
see
tanang
RBC cast in the urine
makita na.
sediment, this indicates that there is a bleeding within the nephron. Okay? Remember
Sila
that the RBC casts are more specific than RBCs in urine. Okay? In the evaluation of nephritis, okay, or bleeding in the nephron. Please remember that. Again, RBC casts are more specific than 3 RBCs in urine in the evaluation of glomerulonephritis or nephritis in general. So RBC casts are orange-red in color, and they are embedded and adhering to some
Dili na mama.
and in some cases,
Ikaw ba yan tiyan gana na siya?
in the tubular epithelium or
Tubig
in
na
the
gana siya
cell,
tubig.
these cells begin to disintegrate.
Sada kanya ni may
And
bit ba?
What happens is
Kana.
that there is an increased
Kanda ko na siya.
urine stasis or flow in the tubules, and that causes the fragmentation of the RBC cast. Okay, so we confirm the presence of RBC casts by seeing the 3 RBCs in the urine sample. And also, we have to correlate it with the chemical evaluation, which is a positive for blood. Okay? And also, please take note that these RBC casts are correlated with specific type of disorders like intravascular hemolysis. Remember the hemoglobin, once it is increased in the circulation, particularly in plasma, it can cause damage to the tubules, and that would result to
No
bleeding.
water.
And at the same time, if the patient is experiencing or has experienced crush injuries or muscle dystrophy or any problem with the muscle, the myoglobin concentration will also increase, and the myoglobin will cause harm to the tubules, and that will also result to the presence of RBC casts in urine. Okay, so please take note of those factors. Basically, or in by basic definition, if we see RBC cast in urine, we're talking about bleeding in the nephron or bleeding in the nephron associated with certain types of conditions.
Atong yellow green.
Remember that in glomerulonephritis, we can see RBC casts more than
Masura.
if we take note of that. So if we are to choose which is the best indicator for bleeding, that is the RBC cast, not the free RBC. And the evaluation of the cast matrix, you have to look for in the evaluation of the RBC cast, you have to look for the cast matrix to avoid mistaking RBC clump for the cast. You have to look for the cast matrix. The cast matrix must be present. The clinical significance: glomerular damage or nephron capillary damage. Glomerular damage, dysmorphic RBCs, and elevated protein, and may be seen following strenuous exercise. Next, WBC casts. WBC casts are mostly comprised of neutrophils and lobe nucleus, and wherein lobe nucleus and granules are seen. Okay, mostly neutrophils, because WBC casts are usually seen in urinary tract infection or pyelonephritis. Okay, once we say RBC cast, we're talking about nephritis, glomerulonephritis. Once we're talking about WBC cast, we're talking about pyelonephritis, okay, or infection of the renal tubules. Okay, infection of the renal tubules. That's why you can see WBC cast, because there is cellular infiltration in the renal tubular epithelium. Since there is WBC infiltration in this tubular epithelium, that would result in the formation of the WBC cast. Okay, so the staining helps differentiate WBC cast from RTE cells. Okay, this WBC cast may be tightly packed, and you have to look for the cast matrix to distinguish it from the RBC cast. And that's the same with our RBC cast evaluation. Now, for the clinical significance, as I have said, WBC casts are seen with infection and inflammation of the tubules. So, pyelonephritis, infection of the renal tubules that caused the inflammation, or that resulted to the inflammation. Okay? Pyelonephritis, WBC cast, and of course, you can see bacteria and bacterial casts in bleed. In acute interstitial nephritis, there are WBC casts, however, there is no bacteria. Because the main culprit here is not an infection. Okay? The problem here is hypersensitivity reaction. Okay? And again, it may accompany RBC cast. Because remember, if there is, it may accompany, it does not mean that it will always have RBC cast. Remember that if there is infection, there is an increased chance of bleeding. Okay? If there's infection, there's increased chance of bleeding because obviously the enzymes or the molecules that your WBC, the molecules or the components that the WBC is releasing will harm the endothelium, and that would result to the presence of RBCs in the renal tubular epithelium, or in the tubules itself. That is why you can see RBC casts. And the next is bacterial cast. Okay? You have to confirm the presence of the bacterial cast using a gram stain. Okay?
Yes!
And it is also seen in pyelonephritis. So again, if you want to compare glomerulonephritis, you can see RBC casts, okay, RBC casts, and RBCs in urine. Together with the chemical evaluation, you can see proteinuria and positive reaction for blood. Now, if you want to see, or if you want to, if it is pyelonephritis, you can see bacterial cast, WBC cast, and bacteria in urine. Now, in comparison to nephrotic syndrome, you can see oval fat bodies and lipids in urine, okay, as well as a positive protein. Okay, so those are the comparisons that you have to take note, so that you will be able to compare and evaluate each case study once you have encountered them in the relationship. And you also have mixed cellular casts. Okay? These are seen in glomerular nephritis. They can be either RBCs and WBCs. And if we can, this is not connected to the bacterial cast. No? Mixed cellular casts are a combination of RBCs and WBCs. Okay? Combination of RBCs and WBCs. So if you want to identify what is the specific type of cast, you have to look for the predominant type of cell that's occupying the cellular matrix for you to be able to identify the specific type of cast. Next is the epithelial or RTE casts, or epithelial RTE casts. So majority of the cells are on the cast matrix. Okay? You can differentiate them for WBCs. Okay, so you use the stain to show the single nucleus. Now, this RTE casts are formed in the distal convoluted tubule. Okay, and you can see the distinct small round cells. Okay, and again, the clinical significance RTE cast, I've said this one, it can be seen in tubular damage. An example of this is acute tubular necrosis. Heavy metals, it can be associated with viral infections, drug toxicity, graft rejection in pyelonephritis. Okay? And the cells sometimes it may appear to be bilirubin stained, and for us to identify it, we have to look for the cast matrix to distinguish it from epithelial cell fragments. And of course, we have the fatty casts. Okay? Fatty casts are observed using polarized microscopy and some lipid stain. Again, the significance of fatty casts is nephrotic syndrome because nephrotic syndrome is associated with lipiduria or the presence of lipids in urine or lipids in urine. It can also be seen in diabetes, fresh trauma, and tubular necrosis. And remember that triglycerides and liver fats are stained with either oil red O or sodium 3. And for the cholesterol evaluation, you have to use a polarizing microscopy. Again, polarizing microscopy. The diagnostic significance of fatty cast, as I've said, it is seen in nephrotic syndrome together with oval fat bodies. Okay, so fatty cast and oval fat bodies, that is indicative of nephrotic syndrome. And then next is we have the coarse and finely granular cast. Okay, you usually detect this type of cast using a low power field, and you have to ID them using a high power field. Now, this granules disintegrate, and once they disintegrate, they form another type of cast. Okay, and that cast is called the waxy cast. Okay. Now, from the granule origin usually originates from RTE, lysosome, and is treated in normal metabolism more after exercise and activity. And also it may come from the disintegration of cellular cast and principle. For example, your RBC cast and WBC casts. Now, we can differentiate granular cast from clumpy disease and crystals. Again, you have to look for the cast matrix. After, we have the waxy cast. Now, waxy casts are well visualized and stained. Now, the diagnostic significance, if we can see waxy casts or many waxy casts in urine tests, it is seen in chronic renal failure. Again, it is seen in chronic renal failure. And as we have seen in our process earlier, from the hyaline cast to the waxy cast, it is the final degenerative form of all casts. These are degenerated hyaline and granular casts. And once seen in urine, it indicates extreme urine status. Okay? Again, it is seen in renal failure, particularly the chronic kinds of renal failure. After that, we have the broadcasts. Okay? Broadcasts are also known as renal failure casts. Okay? Now, it is associated with destruction and widening of the DCTs or the distal convoluted tubule. As you can see, it is quite larger than the waxy cast. Now, this is because of the widening of the lumen of the tubules. And this means that the tubules are less, okay, they are less efficient, okay? And at the same time, it also associates with the imminent destruction of the renal